Recorder from the first table? Anything from about functions?
So we have
So you have an input variable with an output based on that variable, okay? Based on that input variable. Okay, good. All right. Table 2. Jenna, all right. Yeah. What would that look like? What do you mean? Do you mean composition? Can you show me on the board what you all talked about? Okay, yeah. So composition of functions can be written like this. This is actually a little smaller, which means this is the more, I think, common way to write it. F of g of x, f of g of x, where you're inside, this is called the inside function in this particular case, and f is your outside function. So this was a way of combining functions where you take the output of one function and it becomes the input of your next function. Okay, composition. We will cover that briefly Monday. Okay. Table 3. Okay. Okay, so all right, inverse functions, the what swap? Y and X swap places. Okay. Okay, Y and X swap. And then what were you saying for your example? I think you mean 2 to the X. And its inverse is 2 of X. Okay, close, but that's good. Hey, got to jiggle out those cobwebs. All right. Yes, exponential and logs are inverse functions of each other. What was the big property about inverse functions if we think about what Jenna just said? Yeah. Yeah, if you compose a function with its inverse and, whoops, and you change the order of that composition, this is the only time it works, you come right back to your original input. That's how inverse functions work. It's a round trip. So whatever you start with, you end with. Okay, table 4 is already gone. Table 5? Mariah? Okay. Okay, so this is a linear function, yep. Okay. Slope. Change in y over change in x, and that little triangle is called delta. It's small d delta, Greek letter, delta. Okay, and one more table here. Is Bella the recorder? Okay, Bella. Yep. Okay, 3 log, did I write this right, what you have? 3 log 10 equals, oh, so you just, okay, yeah. That 10's invisible if it's the common log, and you have that equals what? 3? Is that right? Everybody get that? Because log base 10 of 10 is 1, 3 times 1, or you can convert this to look like this, and then just lift off the exponent. Okay. All right, so I'm sure you have more than that on your papers, but as you can see, you have a lot up there with functions, and nobody mentioned the actual definition, although this was pretty close, an input variable with an output based on that input. The definition of a log is that for each input variable, you have one and only one output variable, okay? So pre-calc, the purpose of you sitting here is my job is huge. I have to get you ready for 201 next semester. And I know what 201 is about, and I know what the workload is about. So we have a big job to do, and I'm sure we can all do it successfully. So I will slowly introduce you to some of the expectations of the course in the next 50 minutes, but I want to get going with the demo. I want to then do a little bit of the syllabus and some of the stuff you see here. So the first 8 classes or so, maybe then a couple into the next packet, will be like what we call rapid fire review of 107, with a focus on providing more efficiency and proficiency with logarithms and exponential functions. But we're going to cover just about everything. That, like, for example, we spent a week, if you had 107 recently, on transformations. It's going to be just a packet with a summary that you're expected to review. So if you have not had Math 107 recently, then you may want to do some more work than what we're doing in class, and I'll be glad to help you and guide you with that, because I know you're all coming in here from in different ways. Some of you placement tested in here. Many of you I know just had 107 with me or Caitlin or our online class last semester. So I'll try to meet your needs based on what it is that you areas that you need some refreshment on. Okay, so the first thing I want to talk about is homework. And I have an article, but I didn't bother to Xerox it because I know most of the time students don't read them. But I have an article on homework as assessment, and I'm giving you these these little composition books, and I have expectations about how you will write up your homework. And those expectations are clearly, I think, shown here and here. If you have any questions after you leave class and you read this, please let me know. The most important thing I want to emphasize to you is that your homework notebook should be one of the most valuable tools you have in this classroom. A lot of people think that this packet is like the most valuable thing. Well, it's actually your homework notebook. And if you look on the back page of this pink sheet, notice what this student did in their homework notebook. They were working on a problem. They didn't get to where they were supposed to be, so they just put an X through it, reworked it, and then wrote a note over here. Okay? Most of us, what do we do when we make a mistake? You erase. And it's so critical to keep all of your work shown and to reflect about what you just did and let yourself know. Okay, and then down here, another little comment. I suggest actually taking a ruler and making like a column on the left or right-hand side of your notebook for your comments. Sometimes those comments can be, hey, congratulations, I did it, whatever. And there were a few other words I couldn't say in this notebook, but I just took what I could legitimately print out, okay? And there's all types of research that's been done about how important it is to physically write out mathematics. There's something that happens in that act of writing out and with your brain and all your synapses and stuff like that, right? I mean, the problem with these online homework packages is you think, oh, this is cool. I don't really have to think. If I can't do this, I'll just view the example, then I'll just copy it on a piece of scrap paper. Boom, my answer, I get 100 for that homework assignment. No, not going to work, especially given the direction all of you are going. You need to spend some time in ambiguity. You need to spend some time in that kind of chaotic place sometimes that it's a little frustrating, but very enlightening when you actually work through it. So you should think about starting your homework assignment for today's class like you were studying for a quiz. You shouldn't turn on, which I'll show you in a minute, Mom, my Open Math, which is our site we're going to be using. All your books are free now, no cost for your textbook, and you'll have 16 homework problems there. And yeah, you can probably work through them pretty quickly. But think about it. You should be reading section 1-1. Oh, does anybody have the book with them? Oh, I didn't take it in. I knew I forgot something. I'm going to go grab it. This book is so readable. Does that like sound weird? It's so readable. It's like written, it's not like really technical. It's very accessible. And throughout every section, they usually have 2 or 3 try it now problems. And I didn't put on your homework. You have to do the try it now problems. But you should read and take notes before you even start your homework. Right, Kavanaugh? Like I'm going to do that? I'm telling you how to get the most for your money, the most for your future learning, and for your success. I know where a lot of you are going. I looked at your majors. Okay, so this is the time to start employing skills and habits that will serve you better in the future. All right. Some of you need to have those skills worked on. I know some of you from last semester, you need to work on those skills. Okay, and others of you, I'm sure I'll learn about you soon. Okay, so I'm trying to set this up for you for your success, not to be, you know, the other word about it. Okay, yeah, Jackson.
Well, how many times do you want us to like mess up and take notes before we like go use scratch?
That's up to you. That's up to you. It's your book. Okay, it's your book. So whatever works for you. All right. If doing this doesn't work for you, don't do it. I'm just saying it's valuable because when the student comes back and looks at this, they're going to know what they didn't do and what they have to do because there's a little note here. Note to self, right? Okay. What else did I want to say about homework? Okay. So every day you come in here, I'm going to have a grid. And this is going to be part of your daily, I'm going to go into the syllabus now if you open the syllabus. Open to where it says page 1, 2, 3, 4, methods of evaluation. Methods of evaluation at the top. Okay, so you're going to have 2 grades for homework. You're going to have 10% for the homework you do online, and you're going to have 5% for daily preparation. All right. Daily preparation means if you come that day and you're not prepared, well, you're not prepared for that day. So, that's kind of like a 0, right? It's about preparing for that day. But I know how life is. So if you don't have everything ready for that day, I will at least give you half credit for what you didn't do if you get it done some other time outside of class. But look, there's 27 of you in here. Can you imagine if you all show up 2 minutes before 20 of 11? I'm never going to get through, right? So I will usually be in my office at 10 to 10:30. I'll come floating here. If you're early, that would be fabulous. Or if you want to come see me and I can look it over and talk to you and get stuff done before class, that would be really great. So your daily preparation is all outlined here for you. This is really going to be the most critical part of your daily stuff. And you'll get 4 points if your homework is done. All your work is shown as indicated here. 2 points for your class activities, which are about to start as soon as I stop talking, your lesson activities. 2 points for the preview activities. Let me just say every class is set up the same way. Preview activities, and those are created to help you with either introducing you to a topic or refreshing your skills. And then you'll have the class demo, the lesson demo, and then you'll have activities. New this semester, different from 107, is if you turn to page 5, you'll see a section called More Practice. Okay? More practice, especially for those of you who haven't had 107 recently, but there will be areas, page 5, Robert, yep. Keep going. You're too far ahead. It should look like this. Some of you, like as we move along, may want to have a little extra practice with the material, especially if it's totally new to you, maybe like when we get to trigonometry, or some of you have problems with inverse functions. There'll be more practice there. I have answers to more practice on our Moodle site, okay? Answers to all of your lesson activities are always found at the very end of the packet for that class. So they're here, along with your homework assignments, okay? So the more practice, yeah, you could just skip it if you want. You could look it over and just do the ones that you think will help you. Some of you might look at this first, more practice, and say, I know that stuff. I'm pretty good with that stuff, and that's okay. All right? Use it. I put it there for you depending on what you need. Okay? And then the last 2 points you get for being in here by 20 of 11. If you come in late, it's 1 point. So every day you're going to have up to 10 points for your daily prep. If you miss any class, you're responsible for the next class you attend for having all that work done. And I will only grade the lesson for the class previous to the one you're in. In other words, when you come in Monday, I'm only going to be looking at today's class. So if next Friday you got today's class stuff done, you need to see me outside of class for me to give you credit for that. Because it's impossible for me to do, 20, all the variations is going to be. Does that make sense to you? Okay. And really, I'm not a scary person or anything. I like it when students visit me in my office. All right. Take-home quizzes. All your quizzes will be take-home. You can use whatever resource you want, Khan Academy, anything you want, except you cannot use a student in the class or a student at UMass or a math faculty or a studio personnel. It's your work, okay? And you're on the honor code to do that. Exams, there'll be 3 in-class exams. You have 1 page of notes that you can bring in, and sometimes I'll let you bring something in as we move along later. There'll be some things called unit circles and stuff like that that you'll be able to bring in. And then, of course, your final exam. So it's your responsibility to read through the syllabus, and at the end of this first lesson, it says questions about the syllabus for Linda. So as you read through it, you have a nice weekend here to read through. If anything's not clear to you or you see any typos, let me know. In fact, this packet is brand new, so I'm assuming there'll be typos somewhere in here. I mean, I've been working on this since November. I've only got the first packet done. I'm in trouble. So if you see typos or there's an error in the answer key, please let me know, and I can take care of it and fix it. So basically, 15% all in your control, homework and daily prep. Take-home quizzes a little less in your control, but you still have time and a lot of opportunity to do well. 20%, 3 exams for 50, and 15% on your final. No projects this semester. I know. And here I want to stress tentative course schedule. I'm guessing. I haven't taught this class for a long time. Looking at the material and saying, yeah, they really should have 2 days on this topic and maybe 3 days here. But given snow days and things like that, we may have to adjust this. Anytime there's an adjustment to the syllabus calendar, I will definitely redo the whole thing and give you the revised schedule, okay? So please read your syllabus. That's what we're here to do together. And if you have any concerns, let me know. Moodle. Your Moodle site will be used more than you've ever used a Moodle site, probably. It has the syllabus in it, and I have to say I was sorely disappointed that I sent out an email asking people to get back to me, and only 4 people out of 27 responded. And the reason I was disappointed was only because this is my only way to communicate with you, right? Is through your GCC email. Now, some of you may have it linked so that it goes to the email you use more commonly. But if I need to tell you something, that's how I'm going to do it. So please, if you haven't been in the practice of checking GCC email, please, for this course, just take a peek at it every once in a while, like at least between classes, So in case I have to tell you something. Or, you know, if you have a connection with other people in the class, maybe one of you can take that responsibility one week and another person the next, okay? So here's the exciting part. And my colleague Amy Enman did this with her summer students. You only have to log in one place to do your homework. You don't have to go to My Open Math. You can do it all right from here. So here's your course ID and here's the enrollment key. That's all you need once you create a username and a login, and that can be anything. It doesn't have to be even GCC related. So I'm going to show you, I'm going to come in and make believe I'm a student so that I can see what this looks like. So there's my email. Oh, I hope I remember my password. Oh, so many of them. Maybe it's just my first name and not, I think. Let's see if I can get through it first. I hope I can, or I'm in big trouble. All right. So yeah, let's save that. So as you can see, here's a calendar of every day with what we're covering that day. Here's the, there's going to be GeoGebra and Desmos, so the free on software for graphing and the stuff that you would normally do on a graphing calculator, because we don't require a graphing calculator, just a scientific calculator, which I just checked Amazon yesterday, $11.19 for one of these calculators. So given that you don't have to buy a textbook, maybe you can get yourself a little scientific calculator for the class. So this is, and here's your packet here in case you need to review it and you don't have it with you. But I did not put this on the homework, but this little My Open Math tutorial is real quick to go through, and you should all do this first, because like how you write the infinity symbol is different. It doesn't have a symbol like my math lab did. So just check this. This is like 6 or 7 little things to go through. This is like a little like orientation to My Open Math. And right here is the section of the textbook that corresponds to this homework. Notice I have it first, right? So you're going to click on that first. And it doesn't matter that I didn't have my textbook because it's right here. Where is it? Come on. There it is. So here's section 1.1. They have lots of examples. Very, very readable. I'm telling you, this is like one of the most readable math texts I've seen. And once you're done reading that and taking some notes on it as needed, you go right in here, and there's your 17 homework questions. Okay. Now, I have this in your packet. Don't just automatically assume that what's on Mom is all you have to do, because if you turn to page 10 and you look under homework, it says, do the homework assignment in Mom, found on our Moodle site, and number 47 in section 1.1, page 20. So there was not a problem like number 47 in this online homework, and I wanted you to be able to, it's in the textbook, and so I will often do that. So make sure you check, and if you are not checking, please read it up here, because look where I put it also. It says it right up here. In addition to the questions, do 47 in the textbook. Shane?
So is there going to be two textbook to all the over?
Yes, that's what I just showed you. Let's see. Let's get out of here. So this right here, yeah, every single section in your textbook will be right above your homework assignment, and right here, the end of the section. Oh, yep, we're still in 1.1. There are your homeworks. So what one did I want you to do? 47. So 47 is right there. Now, when you write this problem in your notebook, you have to redo this graph. I want to see this graph along in your notebook. Okay, that's part of showing me. I need to be able to look at it, and I should know exactly what you're answering or working on. Okay, other questions? All right, so let's take a look at today's demo. Again, some of this may be review for a lot of you, and I hope I don't bore you too much. if you've had all this recently, but I try to put in some new stuff to keep you interested. Let's take a look here. All right, so we've done a little bit of reviewing functions. And so here we start with our first function. Want to read this for us, the first, Rob? You can decide who's the first, Rob. Okay, so here's a function. It's being verbally described to you. I'm not giving you an equation, I'm not giving you a table, and I'm not giving you a graph. Okay, this is one of the ways we represent functions as a verbal description. So what does the independent variable represent here? What does the independent variable represent? Anyone? Independent is found here, yeah? That's the independent one, x. And what's x, Rob? Right, so x, the independent variable, is the number of years after it was purchased. Okay, so number of years after purchase. Okay. So so x is the independent variable here, and we often use x. Sometimes we use t, sometimes we use d, depending on the context of the situation. And the dependent variable is the notation that we refer to as f of x. This represents the output value, or your dependent variable, because the output value, this function depends on x. This is also the dependent variable. So f of x is what? The value of the car in thousands. That's important, right? So we're looking at the units here along with what the actual variable represents. All right. Once you have that information, then if I give you an equation that looks like this, you should be able to interpret it and write a sentence. So give this a shot. What does this equation mean? Write it in at your seats, and then we'll discuss it. Okay, someone other than table number 3. Anybody else? Yep, Kyle? The car purchased 5 years ago is worth $6,000. Good. Now, you may have that written in a different way, but it's important that you have 6,000, because that's what this 6 means. $6,000 is the unit. Could be euros or rupees. I mean, we just happen to be talking about dollars here. And then 5 years ago since its purchase. So any questions on that? All right, so suppose a car is initially worth $15,000 and becomes worthless after 20 years. Write 2 equations that represent these facts. So how would we do this first one right here with the a car is initially, the word initially worth? What do we do with that statement? Jackson? F of 0 equals 15, correct. Initially means when your independent variable is set to 0. That's what the word initially means. Okay. So when you're interpreting things and you're looking at a starting value, you can always use the word initially, or a starting height of something at a particular time when time is 0. The word initial is often used. Again, you put 15 there because we know that our dependent variable is listed in thousands, And notice I do not have the dollar sign on that 15. You don't put any units in the equation. Okay. All right, how about the next one? It's worthless after 20 years. Someone want to take that one on? Yeah, Ella? F of 20 equals 0. Perfect. So this 20 is referring to 20 years after purchase, and the 0 represents the word worthless. Okay, no value. Okay, so I want you to discuss in your groups which of these 3 graphs below seems most realistic in terms of modeling a situation of, notice we're starting here at 15,000 initially is what the car's worth, and then after 20 years it's worthless. So discuss in your groups, number 1, what the meaning of each of these graphs are, A, B, and C. What does A, B, and C tell us is happening to the value of the car over time, and which do you think is most realistic? So I'll give you a few minutes to discuss that at your groups. So, Brad, I heard you talking about what happens to the value of the car when you drive it off the lot. Sorry for, eavesdropping, but.
The most obvious thing to me is drive it off the car. Appreciate it.
Right. I mean, it's you've heard people say the minute you drive that car off the lot, the value takes a nose dive, right? So in terms of that idea, which one of these graphs did you select? C. Okay. So let's talk about what each of these graphs are doing. So why would you pick C? Because notice, even if you just picked a point, starting, you have your starting point at 0.15, and then you have some point along here. I think that might be like, the numbers are a little small, like maybe 210. You notice that there's a very big drop, right? The value falls very rapidly here. And you can sort of get a sense of that by just looking at this part of the curve right here, right? If you think about how quickly that's dropping, that's going to show you that initially this value drops very quickly, and it's continuing to drop. But what can you tell me about how it's the rate that it's dropping here? What's happening to the rate? It's very, very steep here, but then what's happening? It's decreasing, right? The rate is decreasing. The value is still decreasing, but the rate that it's decreasing is slowing down, right? Slowing down a little bit. Okay. What about A? If you were discussing the rate there, what might you say for A? You thought it was A. Okay.
Well, I mean, I think
All right, it's the same car, but I know it kind of makes sense. You would think that you'd be able to get, your money's worth. In fact, I could probably get more from my car like 5 years out than I could if, like, not even having it for 2 years, or not with much a big differential, So here, what's happening to the value here? How is it decreasing? Slowly, right? It's fairly slowly initially, and then it kind of speeds up, right? It's still decreasing, but then the value's decreasing more. Okay. And what about B? Yeah, Colin? Oh, you did. And yeah? Yeah. Yeah, we're talking about reality. Yeah, if you only have those, if you only use the initial and what's not, when it's worthless, that's the line that connects them. What can you tell me about the value of the car in B? It decreases at a steady rate, right? And we know that doesn't happen. Well, at least if you've owned a car, if you ever had the pleasure of buying a new car. It took me a long time before I could buy a new car, but I now can buy a new car. Of course, I have 14-year-old cars and 13-year-old cars too. Anyway, that's looking at a function described verbally. The next thing you see is sometimes we can describe a function with a table. Sometimes, a lot of cases now, a lot of the textbooks use these horizontal, yeah? The first one? C. Graph C. Sorry, I should have put that down. Sure. No. I'm checking your lesson activities, which are coming up after this, and your preview exercises. Yeah. Nope. If you want to sit there and not write a thing, that's up to, no, some people like to just listen and then they go home and they write, you know, so it's totally whatever your style is. Okay, so this is a numerical representation. We just talked about a verbal and a graphical with the car, the value of the car over time. Now we tend to write these tables horizontally, and you know, many of you probably initially grew up with your tables looking like this. It's exactly the same. Oh, I forgot I still have my magic pen on, so it's all disappearing. Whoa, that's pretty wild, huh? Did I throw you for a loop there? So it's the same as having it set up in your traditional columns, okay? So we're asking a question now, is D a function of F? We're getting back to the original definition of what does it mean for D to be a function of F? I mean, excuse me, D a function of T. D a function of T. So when you hear something like that, it might help you to just think of this notation, D of T. And what's the independent variable here? Which one's the independent variable? T. Oh, I still have that thing on? Independent variable is T. Oh, I don't usually work with this thing. I can see why I don't. I hope I can. Come on. Oh, it's still a magic pen over here. That's why. This is kind of fun. Ah, let's go back to the pen. All right. All right. So T is your independent variable. That's your input, right? Or your input. It's kind of an easier, quicker way to say it. And D of T is your output or your dependent variable. Okay, so we're wondering if D is a function of T. So how do we think about that? Well, initially Kyle said if you have an input variable, you have one output variable. And we edited that a little bit and said one and only one. So if you're a 0, you know you're an 80, right? There's no question. When you're 0, you're 80. When you're 1, you're 128. When you're 2, you're 144. When you're 3, you're 128. When you're 4, you're 80. There's no discussion. It's okay that 0 and 4 have the same output. That's all right, because it's unique for that value of T. Okay, so yes, D is a function of T. Going back to something that you didn't talk about in your cobweb review, is that this function would not be considered to be one-to-one. Because 0 goes to 80 and 4 goes to 80, it's not one-to-one, which means it doesn't have an inverse function, unless you do some restrictions. All right. Is T a function of D? No. Well, I got a quick no on that one. What made you say no? Yeah, because now D is your input value, T is your output value, and if you're 80, you kind of have an identity crisis, right? Because one 80 goes to 0 and the other 80 goes to 4, and we can't have that. Okay, it's not allowed. That's called a relation in mathematics. We're interested mainly in working with functions. Okay, so this is called a relation. It's just any ordered pairs, set of any ordered pairs, but nothing special about it. Function, there's something very special. For each input, you have exactly 1 and 1 output. Doke? All right, so here's the algebraic formula that fits these values. D, and you'll see a lot of stuff written this way now. D is a distance. It's a function of time. And here's the formula that gives you the output variable D. So I'm going to just come up here. I forgot that it was written as D equals F of T. So I'm just going to make a little correction here and just call it D. Take that T out of there for now. All right. So find the intercepts of this function and explain what they mean in the context of the problem. Intercepts, we have our x-intercept. In this case, it's not going to be called the x-intercept, but the what intercept? T-intercept, right. T-intercept. And we're going to have our d-intercept. So the d-intercept is when the value of d, when t is 0. It sits right along your d-axis. Here's your d-axis, here's your t-axis. Okay. And your t-intercept is the value that sits on your t-axis, so it's the value of t when d is 0. Okay. So we're trying to find t when d is 0 for the t-intercept, and we're trying to find the value of d when t is 0. I think I might have said that backwards. We're trying to find the value of t when d is 0, for value of d when t is 0. It sounds the same because it's T and D. I should have used 2 different letters, huh? Okay, so I think a lot of you know how to do this. I mean, you've probably started practicing this a long time ago. So what's going to be the D-intercept? That's the easiest one to find. What's the D-intercept? Huh? No? It's not easy? 80, right, because when you put 0 in for t, all these drop away and your value is 80. Right, so f of 0 is 80. This isn't a very good graph because it doesn't even have 80 on there to show you. So I'll have to change that. Okay, so I can't even graph it unless I make the scale different. Like this would be 8, 16, 24, 32, and then this would be 80. So we'd be right up there. So let's change that scale a little bit. 40, 48, 56, 64, 72. I can still multiply. That's good. All right. And to do the t-intercept, we got to do a little work, yeah? Okay. Ish. Yes, we have to do a little work-ish. All right. So we have to solve the equation when d is 0. So we have to solve for t. What kind of equation is this? Quadratic, right. This is a quadratic equation. And table 4 put up the quadratic equation at the beginning of the hour. To solve this equation, you write another equation. I don't want to see b plus or minus. I want to see another equation. T equals the opposite of b plus or minus the square root of b squared minus 4ac over 2a. Now you can do your equal sign all the way down. So what do we have? B is 64, so negative 64 plus or minus 64 squared minus 4 times negative 16 times 80. Oh, this is a monster. I hope someone out there has a calculator over negative 32. So this equals negative 64. Does anybody know the square root of 64 squared off the top of your head? 4096, thank you. Plus 4 times 16 times 80. Everybody got that done? 5120. All over negative 32. Now throw those together. I'm relying on all of you. I could put it in a calculator, but you have calculators out there? Is this a pain in the butt? Yeah. I could have factored this in like 2 seconds. But you have such an aversion to factoring. All right, come on, you like your quadratic formula. What is it? 9,860 or 16? 16 over, and what's the square root of that? 96. Okay, plus or minus 96 over negative 32. So we get a negative 5 or we get 1. All right. Any chances you're going to probably mess up somewhere along the way there? Yeah, but you know, that's life, right? You might make a mistake. Most of the models that we use in real life don't factor easily, right? But don't necessarily always think you have to use your quadratic formula. At least check out whether you can initially factor it. Now let me just show you how quickly you could have factored this. First of all, it's an equation, so you can divide both sides by any number, any non-zero number. I love t squared to have a 1 in front of it whenever possible. So I'm going to see if I can divide negative 16 into each of these numbers. Well, I can divide it into itself. So go into 64. 4 times, right? Negative 4. And, oop, that's supposed to be an 80 into 80. 5, right? So the first thing you can do here is you can divide, oops, I don't want to do it that way. That's not good mathematics. Divide both sides by negative 16. And what would I get? I'd still get 0 on my left-hand side, and I'd get t squared minus 4t plus 5. How easy is that to factor? T minus 5, t plus 1. Is that correct? Oh, I made a mistake there. Anybody catch it? That's not right. That's right. It's supposed to be negative 5. All right. Got to watch me. I'm slippery. All right. Minus 5. So it's t plus 5, t minus 1. And now you set each factor equal to 0, and you get t equals negative 5, t equals 1. That's a lot faster. So if you started putting in these points, and you got this point here, at some point this thing is going to reach a maximum height because it's a parabola. It's an upside down parabola because that sign tells you that. We know where that highest point is going to be because the t value of our vertex is minus b over 2a. So that's negative 64 over negative 32. It happens at time 2 seconds. So now I look at f of 2, and I throw 2 in here. And I get, I believe, 144 if my memory serves me. So up here, way up here, I've got my maximum height. And so mathematically, this is what the parabola would look like. So the domain for that parabola would be all real numbers. The range would be from negative infinity up to 144. Nobody talked about domain and range in their cobwebs scenario. However, often you will find your domain and range are different than the mathematical equation based on your situation. We're not going to be talking about time being negative 1 here. In fact, what value of t would this situation most likely start if I was representing some kind of distance over time? Where would my domain start? 0. So I would just erase this part of my graph, and I would start right there. Okay? So my domain, realistically, my domain for the context, I haven't told you the context of the problem, but it's throwing a ball from a height of 80 feet, right? So your domain here would be 0 to 5. You would erase this part of your graph as well, unless your object goes into the ground and continues to go in through the ground, but you know, that's not realistic. And your range starts at 0 and goes as high as 144. Oops, brackets. Brackets on both of these. Brackets, if you recall, includes the endpoints. Parentheses do not include the endpoints. This is called interval notation, in case it's been a while since you've done interval notation. So what might this function represent? A ball being thrown from 80 feet, thrown upwards, and reaching the ground 5 seconds later. Oh, in the graph? They are? Now you're telling me? Oh. Oh, sorry. See, I said it was easy to factor, and then I screwed up, didn't I? Yeah, all right, there you go. It's because I'm hurrying. We know that, right? When we hurry, haste makes waste. All right. So what might the function above represent? We talked about throwing an object upward into the air. It's going to reach some maximum height, and then gravity's going to bring it back down to Earth. Okay. So here are the 4 basic ways to represent a function. We've done all of these in the preceding examples. I think you can find them if you look back, which one was the verbal, which one was the graph, etc. And I want to give you some time to work on your lesson activities. Okay, there you go. I will check these on Monday, along with the preview exercises for lesson 2 and your homework. Okay, that's what I'll be checking Monday when you come in, just so you're clear.